Hello everyone, March 19th. Uh, Still busy, but I think I'm a little bit coping a little bit better. I mean, at a certain point, if you can't do something, you just have to not do it. Or you have to, you set up a goal. I mean, for me, I set up a goal at the beginning of the day. I say, today I want to finish this, right? And at the end of the day, or getting to the end, you'll realize, you know what, yeah, this is not happening. So we can either push forward to get whatever your goal is to get it done. I mean, there's always a way, right? But then you start to sacrifice stuff. You sacrifice the stuff you don't want to sacrifice, or you just you'll start to hate life. That's where the burnout comes in. I can definitely see the way that I work and the work that I'm doing. If I'm not careful, it'll be very easy to burn out. Very easy. And I'm talking about just getting the job like 6 months, and it's already feeling like this way. Because no, there's always so much to do. That's why I'm keeping on my training still, right? Like there are periods of time in the day that just uh, so strict. Like I will not budge and not compromise at all, because those are the time that the periods that make me sane. Like doing this, right? Doing this is a part of it. Doing this, my two training sessions, right? That's like, each session is about an hour, so two sessions including warm up. I say like running close to 2.5 hours, and doing this, I don't know how long it's gonna take. Usually, no, we'll call it half an hour, right? So that's 3 hours. 3 hours plus, right? I also have the commute. To a certain extent, I consider commute is also kind of a deloading for my mind. I could just get away from work. I mean it's not the most pleasant commute, but still get to do stuff. I get to read some stuff. I do my Spanish, right? Doing this, and like there are these things that I think are very important to keep me distracted. So I won't be completely bogged down by whatever happens at work. But big things are happening tomorrow. I will be conducting not really interview, right, but just talking to the candidates. So it's very wild to think that 6 months ago I was on the other side of the coin, right? I was on the other side trying to get in, and 6 months later I am already um, on this side, and then making judgment calls. I mean, it's not an interview, but I think I still have a say. Like if I don't feel things are right, or what they say, if the vibe doesn't match, then yeah, I have the power to say no. So we'll see what happens tomorrow. It'll be an interesting experience. I definitely need some prep. I think I'll write a little general guidelines of what I want to talk about, and make sure I don't talk too much to give the candidate a chance to say stuff as well. I mean, I always think these type of interview is it depends on what type of questions you ask. If you ask the right questions, you definitely can get a lot out of the conversation. I think I know what type of quality I'm looking for. I mean, all the candidates look very strong technically, so I don't doubt, right? I have no doubt that they will success. They'll be successful in what they do. But I take it back. It's not about success. I have no doubt that they are proficient at a task, right? But what I want to know is how will they be able to handle stress? I feel there's a lot of stress in the team, and not just my team, but the overall team, because things are always pushing forward. There always new stuff. There always new demands. and it's hard. I feel like it's hard to keep up, right? To keep up. So that's something I want to look for. It's also something that I think I'll think to myself, as well. How do you keep up with all the constant changes or shifts in focus, and also just the amount of work that's required to get to the destination. Yeah, it will be an interesting conversation, and I'll conduct two interviews, two chats with the candidates. We'll see. We'll see how it goes. All right, one more thing I want to mention is I got an email from my internet provider that they are doing a planned maintenance today. No, actually tomorrow at 12 a.m. So I better finish this one quick. And for cry out loud, we got a hard problem today. So, and an unsolved hard problem. All right, let's see. We have an undirected graph with n vertices labeled from 0 to n minus 1. Okay, 0 to n minus 1. You're also given an integer n. Oh, hold a second. I need my water. Can't do this without water. All right. What are we seeing here? So we have n minus 1 nodes and n edges. N edges. So, okay, n nodes, n edges. And an array edge, we have have vertices and a weight. It's a bidirectional, right? Yeah. A walk on a graph is a sequence of vertices and edges. The walk starts and ends with a vertex, and each edge connects the vertex that comes before it and the vertex that comes after. It's important to note that a walk may visit the same edge or vertex more than once. The cost of a walk starting at node U and ending at node V is defined as the bitwise AND of the weights of the edges traversed during the walk. In other words, if the sequence of edge weights encountered during the walk is this, then the cost is calculated as their AND. Where, yeah, you're also given to the array query, where query I, for each query, you need to find the minimum cost of the walk starting at state vertex Si and ending of Ti if there exists no such walk. Return -1. Ooh, wow. Wow. Okay, so I have 0, 1, 3, but nobody connects to 4. 2. And 2, the price is 1. Alright, so this is 1, 1, 1, 1, 1, 1. This is 0, 0, 1. Alright, so turn into binary. Help us see clearer. Okay, so we want to go from 0 to 3. We have many ways. So first question is, do we always want to go without experiencing? That's not true, right? Because in this case, if you go direct there, you'll get 1, 1, 1. But if you visit 2, so you'll get 0, 0, 1. Right, so it becomes 0, 0, 1. And then, yep. Alright, the second one, we have 0, 1 and 2. So 0 and 2 is 7. 0 and 1 is 15. 1 to 2 is 6. What's 6? 6 is 1, 1, 0. 1 to 2. Wait, hold a second. Wait, what? I can have multiple edges on a pair of nodes. Holy crap. So 1 to 2 have 2 paths. Oh. And the second path is 1. All right. So we want to know from 1 to 2. Well, I'm not sure. Can you do that? You can. Once like 1 to 2, 2 to 1, and 1 to 2. Oh my lord. And it doesn't really matter. You can go 1 to 0, 0 to 2, and then 2 to 1 and 1 to 2, right? You can do whatever because you can pick whatever weight you want. And the minimum is always what? Always 0, right? The minimum is always 0. I don't know, what on Dijkstra? I mean, you can't really compare. Well, I mean, you can. So Dijkstra is every time you add, right? Every time you are at a node, you have its cost, right? And then you pick the smallest. And we are doing the same thing, right? You pick the smallest. But the next one, you have the current weight. You always do the current weight plus. But here we say we don't do the current weight plus, we do the current weight and. Right? So but each one did the extra. I am not sure. How long the query? 10 to the 5th. I mean, we can try. I'm not even sure Dijkstra can work. So here I have. Oh. I feel there should be a different way. All right, 0 to 3, right? So I saw 0 to 1, so the cost is 7. And from 1, I don't choose, so I have 3 options. To 0, but 0 start cost is 0, right? So if I do this, the cost will be 7 again. So we don't do that. Or I can say I can do 3. Well, when do you end? It's not the first time, right? So we do 3. So cost is 7, but everybody starts with infinite, so I think this is good. So we go to 3. And then I will go to 2, and then the cost goes down. So the next actually will go to 2, because the 2 has a smaller cost. And from 2, I'll go back. Right, from 2, I'll go back, because I have to go back, because it's a 1. Right, it's a 1. And then from 1, current. Right, the current cost. Uh, and then from here I do again, right? So I can go to 0, I can go to 3. Oh, I can go to 2, and then there's 1. So I don't go to 2, because if I go to 2, it's the same. So no need to go to 2. But I can go to 0, right? Or I can go to 3. Both will become 1. And then we starting from this is 1, and a 1, and a 1, and a 1. So you don't go anymore. So you don't. So like basically from here, I have no way to go. So we end, right? Okay. So I think Dijkstra will work, but in this case, I go here. I should. We'll go to 0 to 0, 1, right? Because that's the smallest. And then from here, I can go back. Or becomes 0. Then you'll say don't go back. So if it's equal, we have to go. If it's equal, we have to go. That's not good. Okay, we can say everybody starts with infinite. Including the starting point, which starts with infinite. Because we allow it to come back. So we come here, then we'll come back. I have 2 ways. One way was 0, so we go. Yes, yes. And then 0 will come out 0. Okay, so. And it didn't say that it's a connected. It's not necessarily connected, right? I think Dijkstra is definitely not the way to go. It'll take too long. I feel like we need to figure something out. Figure something else out. But how? Well, I think we need to find a path that Maybe we have to go from the path. To get it small, right? We need to find the path with a edge weight that had a lot of zeros. And the question is, can we incorporate this path? So basically we have two nodes that we know if the path coming through this edge, it will always be reduced to whatever, right, it is. Or we can end everybody. Right? We can end everybody because it doesn't really matter. If we end, okay, now we can we find all the connected nodes, right? We find a graph, connected graph. So we have 1, we have 2, and for each one we'll end all the edges. By ending all the edges, we are actually finding the minimum. Right? Holy shit. Maybe that is the solution. Because you can visit any node any number of times. Then, if two nodes are on a connected graph, then there's always a way to visit every single edge before you get to your destination. So all we need to know is end everybody. Right? We just need to end everybody. And if you end, and that is a solution, this is to end everybody because it's an end, right? So as long as you have a position as a 0, it's always going to be 0, it remains 0. And if there's a position as 1, and everybody has 1, there's no way for you to reduce it. So I think the problem changes into doing DFS and just to search for, no, not really search for, but we'll DFS the entire, so we'll create a graph, right? And we'll DFS the graph, try to find the total cumulative end of all the edges, which honestly we can do. Yeah, that's okay. Let's just do the thing, and we'll have. But we also want to know. Maybe union find is simpler in this case. Because given a query, we want to know if they belong to the same, right? So let's say if we do union find. If I do union and find, I can union everybody together, but how do you so I do it twice. Like I union 0 and 1, and now union 1 and 3. I union 1 and 2, right? And then I'll find 0 and 1. That'll give me a parent, and that one will hold the exclusive the end. And then the next one I'll do the end, next one the end. Then I have the end for every single parent. So I feel like union find will be a better solution, except that we have to code union find, which I'm not sure if we're in the mood for. But if union find make things easier, then we will do union find. All right. So if I remember, so I have the DSU here. So what do I need? I need the rank. We'll have the parent. Yeah, I think everything is public. It's fine. We just do a public. Okay, and we also want. Wait, is that not how you define? Oh my goodness, I still don't know how to define rank. And I believe it's called DSU. Let's say this equal to. Oh, it doesn't even work that way. Alright, I forgot how to do it. C++, class, constructor vector. I such as before. I never remember how this is supposed to be done. So I do that. My vector size. Constructor initialize a vector with a specified size. Elements default to. Oh! Oh! Wait, hold a second. This works? I forgot which one I pick. And I guess this is the only way, right? This is the way that's, I think, good. This basically already initializes, so I can just push. Okay. So I can say for int I, 0 I smaller than n, I plus plus. So parent dot push back is going to be I. Rank dot push back, everybody will be 0. Okay, so that's that. Then we all say int find. So find the parent of x. So if parent x is not equal to x, parent x shall equal to find parent x. Right, and then we'll return parent x. I hope this is right. I'm not very sure. Parent x is not equal to yes. So we need to find the parent x and assign it to parent. Okay, so that's fine, and now we need a union. Union, I usually do Boolean union x and y. Okay, and we say parent x equal to find x, parent y equal to find parent y. And if px is equal to py, return false. So this is already union. Otherwise, if they're not the same, then we say if rank px is larger than rank py, if that's the case, then we'll do parent py shall equal to parent shall equal to px, right? Because px ranking is higher than the py's ranking, then parent py shall equal to px, I believe. And then else if rank px is smaller than rank py, right? In that case, then px's parent need to point into py. Else, if they're the same, then we do parent py equal to px, and we say rank px plus plus. And after doing all that, oh, okay. Let's do underscore. It feels like union is a special word. So now return true. So I'm not sure if it's right, but let's pretend that it is. Okay. So we can say DSU equal to DSU n right? And then we need to for auto e of edges. So int u e0. I don't need that. So we basically say DSU dot union e0 and e1. That's about it. Right? We will union them. And then we need a map. Or not. What do we want? We want can we say std vector sum on the sum is the path end Oh, this is possible? I'm actually not sure. Let me double check, see if it compiles. Oh. Oh. Maybe I can just comment them out. Undefined symbol. I guess you have to have main, right? How about this? It compiles. Huh. Then I don't have to do it this way. But I guess you have, because we initialized it here. Okay, so now we have the path and, right? Then we say but we don't know how many parents there are. Therefore, I changed my mind. I'm gonna use an order map. An order map path end is the same thing. And then for our E of edges P shall be DSU dot find E0. Okay, so find as parent. If path end dot contains, actually I don't know, how do I find key in an ordered map? Find count contains my map dot contains. Yeah. How do I initialize a empty? Oh, we just do. This one works. This one shall work. So contains P. Oh, I was like, why there's no? Because this one's wrong. Yeah, if it contains P, then we shall say path end dot path end P and equal to E2, else path and P equal to E2. Why you always just say path and? It's not and, it's and. Okay, so we go through both, right? And then we can say res auto queue of query. Okay. P0 dsu dot find q0 p1 dsu dot find q1. Okay. If p0 is equal to p1, then res dot pushback path and p0, else res dot pushback -1, and at the end we'll return res. All right, let's see if this one works. What are we looking at? 3108. Use the key insight is that the minimum the key insights are twofold. First, if the two nodes in the query belong to a connected graph, we can traverse all the edges in the graph to go from one node to the other. Second, the bitwise AND of all the edge weights in a connected graph produces the minimum path, minimum cost. Thus, we use DSU to establish connectedness and compute the total the bitwise AND of all the edges in a connected graph. Then when we query, when we do a query, we check if the two nodes are in the same connected graph, and if the answer is yes, right, we return we use the bitwise AND of all the edges in the connected graph as the answer, as the minimum min cost for the query. All right, let's see if the magic works. I'm not very confident with the DSU, but we'll see. Address sanitizer. So something's not right. Huh. Where have this issue happened? Allocator, deallocator. I don't understand. I don't want to, but I guess there's no more choice. We have to bite the bullet and maybe run a little debug session. Oh man, I wish. Let's not. Let's just do it here. X parent X. And let's also just use the first one. That's what we find. Does it give standard output 0? 304. 300. What? 304. What did you use find? Oh, for one, this should be Y. Maybe that's the reason. Because you're going PY, this is a random. Oh, I think this probably is right. That's a little typo. Okay, so in both case, and make sure it works. Looks solid. Let's submit it. Hopefully it works. It does. It does. So our idea was right. Our idea was right. Not bad. 179. 74, 70. Of course it's not as fast because we are using DSU. And the reason we use DSU is because union find is just so much easier to write the code. I mean, otherwise you have to go, let's say DFS, right? And as you go DFS, you have to create, nodes that you have visited before, right? You have get that. And similar, you have to get an order map. Well, I guess for that you don't need an order map. It can just be a regular map. Okay, I'll give you that. You can get a regular, not a map. An index array can do that. Yeah, it will work. It will work, and you don't have to go repeated. I actually think it is a more attractive solution. Maybe we want to try again. I mean, DSU, it's easy to write, and then it has all the benefits of just getting things done fast. But now, if we want, maybe we want a little bit of performance. Let's try DFS and see if we can get a bit better performance. All right, so we do have to get a I could call it void DFS, right? So we need graph. Okay, we need graph. We need current node, and we need a graph, which is going to be an unordered map. Oh, I wonder. Right, so we have an ordered map of graph, and we need an ordered set scene, and we also need call it path and of course all of them should be passed by reference. So pass by reference. This is also reference. This is also reference. Too few template. Wait. What's unordered set? I think we need a Oh, but you also need to know which group they belong to. You know what? I think it's actually not as straightforward as I had expected. So let's just call it union find. I think it just directly used this. Oh. -1. Oh, I see something that we might be able to. When we do auto, instead of copying it, I think we should get a reference. Yep. That shaved off a lot. 91, 53, 25. Use reference for the for loop. All right, so just need to remember, always use reference. I think I don't know the difference between reference and pointer. And of course, BFS will work, but I feel like it's just a gigantic amount of work. DFS as well. You need to not only do this, but also the mapping. Right? You need to do the mapping. Component. Visited, yes. Component. But query. Component. Oh, component. Yes. It's the same idea. Yes. Agree. Oh yeah, this is all set bit is 1, right? All right, that will be it. Actually, I like this one a little bit. A little bit ingenuity, and then you will be able to get it. Okay, that'll be it.